For the next question, we have let f of x comma y equals to e raised to the power x squared equals y. Find the second order Taylor expansion of f around the point 0, 0. So it's very clear this is a multivariable Taylor series expansion, and we know that for a single variable, for us to actually know how to approach this, we need to first of all know how to solve a single variable Taylor series expansion. So from my previous knowledge, you know that for a single variable Taylor series, we have the formula to be f of x to be equals to f of 0, right, plus f prime of x multiplied by x divided by 1 factorial plus f double prime of x multiplied by x squared divided by 2 factorial plus f triple prime, the derivative of x multiplied by x cubed all over 3 factorial plus and so on. So it's going to be the same approach with the multivariable calculus. For multivariable Taylor series, we need to know that when we want to expand a quadratic function, let's say x plus y order squared, this is simply x squared plus y squared plus 2xy. So just keep this in mind. It's going to help us to recall the formula for multivariable Taylor series. So once you know this, right, so for multivariable, we know that the formula is simply will simply be f of x comma y should be f of 0, right, plus the partial derivative with respect to x of our function f multiplied by x, right, plus the partial derivative of our function with respect to y multiplied by y plus a half the partial derivative squared of our function divided by partial derivative with respect to x squared plus a half the partial derivative square of our function divided by y squared plus the mixed partial derivative squared of our function with respect to x and with respect to y of x, y. So this is all we need to know. You need to understand, you need to know this formula. So what you need to do is simply to calculate the different terms and substitute, and that will be your solution. So we know our function to be f of x comma y to be e raised to the power x squared equals y. So the first thing we need to do is to actually calculate our partial derivative with respect to x, right? So to do that calculation, what we need to do is actually, this is a product, right? We see that this is a function of the form uv, and we're going to calculate using the product rule. So from the product rule, for those who are familiar, if we have a function f of x to be equals to uv, then the derivative of our function f prime of x will simply be u v prime plus vu prime, where f prime, v prime and u prime are the first derivative of the function. And so if we apply that here, so f prime of x comma y will simply be, or the partial derivative, let's put it that way, the partial derivative of our function f with respect to x, right, will simply be equal to, we're going to keep x e raised to the power x squared constant, then we differentiate cos y with respect to x. Let me just put it that way for simplicity, plus this time around we're going to keep cos y constant, then we differentiate e x squared with respect to x. And if we want to simplify that, the result will simply be, this will simply be the derivative of cos y with respect to x. Since cos y the derivative with respect to x is actually the derivative is 0 because this function is in terms of y, so this will simply be 0 plus, now the derivative cos y is constant, And now the derivative of this function of e raised to power x squared with respect to x is actually 2x e raised to power x squared. Now let me show you how I did that. So let's differentiate. So in this case, we have our function to be, let's put it this way, we have our function to be f of x to be equal to, let's say y equal to e raised to power x squared. So if you take natural log on both sides, you'll be x squared ln of e. So ln y will be equal to x squared. So looking for dy, I'm taking dy on both sides, right? So the derivative with respect to, well, x on both sides of ln y should be equal to the derivative with respect to x of x squared. So this will actually give us dy all over dx multiplied by 1 on y to be equal to 2x, because we're differentiating with respect to x. So dy and on dx, which is what we're looking for, will simply be 2x multiplied by y, 2x. But we know from here that y is e raised to power x squared. So this is the derivative. Again, you don't have to do this in an exam. This is simply to show you how I got to the answer. So this derivative, to conclude, will simply be 2x e raised to power x squared cos y. Now we have to do the same thing for the derivative of our function with respect to y. So it's going to be the same thing. We have our function is e raised to power x squared cos y, right? And what we have to do here is, it's, well, product rule once more, right? So I'll not show all the steps. So this will simply be ex squared multiplied by cos y prime with respect to y in this case, plus, now we are going to keep cos y constant, then e raised to power x squared with respect to y. So this will simply be e raised to power x squared into minus, the derivative of cos y is minus sine y, right, plus the derivative of e to the power x squared with respect to y is 0, so it's 0. So this result will simply be minus sine y or minus e raised to the power x squared sine y. Now those are the different solutions for the derivative with respect to x and the derivative with respect to y. Those are the two solutions. I'm not going to be completing the entire solution, but you get the idea, because I don't want the video to be too long. So the next thing you have to do, which you're going to complete, is to look for the derivative squared of a function with respect to, well, it's like the second derivative, like the derivative of the first derivative. So to write this is actually the derivative with respect to x of the derivative of x with respect to x. The partial derivative, we already saw this, right? We already saw this to be this. So you simply take this and insert here, and you look for the derivative with respect to x. I already did a detailed solution from my previous, from one of my previous videos. So if you don't know how to compute that, you can watch that video on how I am computing the derivative of the second derivative, and you'll be able to get the idea. But it's actually the same approach that I've already used here. So it's very similar. It's very, very similar. So the next thing we need to do is the second derivative with respect to y squared. Again, the same thing. If you notice, I'm simply breaking down the formula. So this will be the derivative with respect to y of our derivative of f with respect to x. With respect to y, actually, because it's y squared in the denominator. So again, this, right, we already saw this. We already saw this is this. We insert that, we look for the second derivative, and here we look for the first derivative, and so on, right? The next thing you need to compute is the mixed derivative, right? Is a mixed derivative, and this also is very simple because we have actually done it already. So this is a derivative with respect to x of our derivative of our function with respect to y. If you notice, we have already done this above, and if you compute everything correctly, you should be able to end up with, again, I don't want to waste a lot of time, all right? If you compute everything, you'll be able to end up with the solution to the f of x comma y to be equal to 1 plus x squared minus a half y squared. So that will be it for this video. So see you in the next one.